Okay, continuing on. So problem two on the review will not be on the final. I was not able to figure out a way to do this um, in a good manner for a multiple choice test, so I said forget it. But I have replaced it with something of similar difficulty. So all these points you'll find out at the end of the test which what is going on with this. So I think you guys will do fine on that portion of the test. So as for the next page, data suggests that a selected college student eats breakfast with a 0.45 probability. Um, so if five students are selected, what determines the probability the fourth person eats breakfast? So if we've got five people, probability this guy eats breakfast is 0.45. Probability the second guy eats breakfast, 0.45. Oh, the third person, 0.45, and the fourth person, 0.45. So it does not mean you have to multiply any of this. The probability that any randomly selected person in this data set is 0.45. So that being said, I think that, that's pretty self-explanatory. It's not a trick question, but it says if the students are randomly selected to determine the complement of the statement, at least one of the five students eats breakfast. So if you have this world, you have people who eat breakfast, while students, and don't eat. Obviously, I've made it bigger. It's not proportionate because this is 45%. It would be closer to about halfway for both. But with that being said, probably that at least one person. So if you randomly select any person, let's say you pick five people, you have to choose. If you want at least one of the five to eat, you have to choose at least one person here. And the other four could be over here. And that would meet that criterion. Let's do it with red. Now, if you choose, in order for you to choose at least one, maybe you choose these two red ones, but then the rest of them fall out here. Or blue. Maybe you choose these three. And these two. Somewhere in either realm, and then the next one. 1, 2, 3, 4. And you choose one here. And finally, 1, 2, 3, 4, 5, and obviously none in the other section because you're choosing them 5 at a time. But with that being said, in order for you to choose at least one, this would be at least one. This is at least one because there's one of them in here. There's one of them from each of these actually. But so to get to the complement of that statement, you need to choose where you don't choose anybody in here at all, which would be if you choose in here. So the complement of this statement is that none of the five eat breakfast. And so that would be if this happened, that green happened. Okay, so it says determine the probability of the complement. So how do we do that? Well, we've got five people we're choosing. We know they eat breakfast with a 45%, so they must not eat breakfast. At a 1 minus 0.45 or a 0.55. If we're going to use a calculator for this, we go 0.55 to the fifth, 0.0503. So what that means is that there's only a 5% chance that all five people picked do not eat breakfast. Which is pretty accurate, right? Because any person you pick's about a 50% chance. So if you pick the first person, there's a 55% chance they don't eat breakfast, which is a little better than halfway, but not. I mean, it's still kind of close to each other. But if you want to find the probability that at least one of the students eats breakfast, Then you're going to do 1 minus P of A. Oops. Which is the complement, which is 1 minus 0503, which is 1. Oops. 0.0503. 9497. So your answer here would be 0.9497. Okay, so it says a scientist conducts a experiment with flowers, and one sample has this many red and this many white. Do the following, find a 95%. Well, I think you guys know what the CI stands for, estimate of the percentage of, let's say it's white. Okay, so if we were to do a confidence interval, we're going to use our calculator, and we need those numbers. So we're going to do a stat test. Now, just to point something out, if you're doing a test, you're doing a hypothesis test. This is not necessarily a test because this is a, what do we call this? A confidence interval. So that we're going to use one of the ones that says int on the side, int, interval. Now, how do I know this is a one prop z int or t int, which either, how do I know that? Well, I know that because it's giving me a proportion of red and white flowers. So one prop z int. Since we want to know white, we need to know how many white ones there are. There are 84. Oops. Wrong one. For the next part, we need to know how many total there are. 84 plus 242. 95% confidence interval, calculate. So 0.2102. So this is between 0.2102 and 3051. If that's what it said. Yeah. Okay, so there's our interval based on this. If the scientist expected 25 to be, let's say, white, like we did in the first part, given the percentage of white, given that the percentage is greater than 25%, I don't necessarily think it is in this problem, but anyways, so let's see if he's correct based on the numbers from what we've chosen in this problem. If we look, this is the range that, so from that number and up until 3051. So from there to there. Oops. There are so the true, remember, a confidence interval tells you the true proportion, and it falls somewhere between these two numbers 95% of the time because of the confidence interval we chose. And so the true proportion should fall somewhere between there. Could be 24, could be 28.7, could be 28.023, could be 29.6, could be anything. However, they predicted 25. Well, 25 falls in that range, so that would indicate to us that the scientist may be correct in this instance. So remember, so your statement would be something like 1 is 95% confident that the proportion, the true, well, maybe not the true, the proportion is between 0.2102 and 0.3051, and the prediction of 25% falls in line with this. And so obviously then that would indicate that this scientist was correct.